My name is Caleb Olson, and this is the Google Location Statistics Engine. I decided to take this project on myself, so I'm the only project member. I have experience in Java and SQL. I got my experience in SQL through my internship at Pedigree Technologies. I've been a backend developer there for a little over a year. I settled on Angular, Spring Boot, and Postgres for my frameworks. I was going to do MySQL, but I couldn't get that to deploy locally, so I stuck with the existing Postgres um, installation that I had from the assignments. And then I used Angular because that's what I learned in advanced software development this semester. Prior to that, I didn't have any front end knowledge or experience. And then Java because that's what I have been using since I started developing is Java. So I use Spring Boot to connect all three of them. And then the idea behind the location statistics, or sorry, the idea behind the location statistics engine is that Google stores your location information in a JSON file, and they have multiple attributes in that JSON file, and they allow some statistics to be calculated, but not all that are possible. I wanted to expand on that and calculate some interesting statistics based on the information that they have. This is my final schema design. I decided to flesh out the information they have in that JSON into two main tables. The one is an activity and one is a place. The activity I decided to store in its own table because most of the information isn't redundant. The place I decided to flesh out into the place visit and the place itself because you can visit one place many times. Uh, so that like for example your home, my home address in Bismarck was 2338 Point Place, and that was the name that was stored in that JSON file, and that occurred so many times because of course I'd visited home so many times. To avoid redundancy, I stored it once in a separate table and then linked the two with a link table. But I later found out that it would be better for me to just store the ID of the place in the raw place visit, since it is a many to one relationship going this way. Um, and a link table is really only useful if you have a many to many relationship, otherwise it's just redundant. But that was something that I didn't find out until late into the back end development of my project, and it would have required complete restructure of the queries that I had already developed. So I decided to go ahead with it and just bring it to the forefront in this presentation and acknowledge it. Another thing is the selection for the data types in this schema design, something that I picked up from my experience at Pedigree Technologies, my internship there, is that when you're designing a table or a database, you want to pick the smallest data type possible that can still store the data. Especially with this particular application, it's extra important because of the size of the data. The JSON file that I'm going to be importing in this example is going to be 6 million lines long. Um, and that's just for one user. If I were to deploy this and say 400 people decided to use it, that's 400 times 6 million. That database is going to grow very, very quickly. So it's important that I make sure I can save where I can. For example, I can use small int for the location user because there's only going to be so many users, I would imagine, and then I need to store um, a slightly bigger data type for the place visit since there's so many lines per user. So I decided to pick integer with that along with all these other selections for their various reasons. Um, and then here's the top five queries that I'm going to be demonstrating, the statistics that you can run through the front end of my project. Top five most visited locations is exactly the way it seems, and most of these queries have filters for the user and time frame that you want to select from. Um, Close proximity is an interesting one. This one's going to be the most complicated query. There's filters for the location record time window. So you want to see how close you were with another person. You can set the grace period for those record proximities to be, see if they were within each other's like specified distance, which is another parameter, within 30 minutes or within 5 minutes. Then of course the time frame window for that as well only grabs stuff from 2016 or whatever. And then these last three are pretty simple. Longest location visit, so select the place visit that has the longest recorded visit time, and I'll go through that in the back end along with the rest of these. Most common activity, so just return the most common activity, and then the activity distance. Select the total, so this uses the sum feature in Postgres or in SQL. Select the total recorded activity distance, and then of course, like I said, for all of these, they have filters for the user and the time frame window. And we'll move on to the back end. So the back end of this project is mostly just it's pretty simple. Most of it is just linking up to the front end. The meat and potatoes is going to be in these data access objects. These are called by the service objects, and the service objects are called by the controller, which constructs the API, generates the endpoints for the front end to hit and pass all this data through, and get sent to the database. But we are going to focus mainly on these data access objects here. So we'll start with the user a the user DAO is just CRUD functionality. That one doesn't have anything interesting. And there's CRUD functionality in all these data access objects. They're mostly just they exist in case I want to expand on this project in the future, but most of them aren't used. So we'll start with activity segments because they're pretty simple here. Fetch most common activities. So here, this is a pretty simple one. We're going to select the activity type from the raw activity segment table, and then we're also going to select the count on the IDs to see exactly how many occurrences of each activity type there are. The where clause is going to have the user ID and the start time and end time, so you can filter within that time frame window and grab the specific user that you want. And then we're going to group by activity type and order by count, descending. So the most common activities will show up at the top first with their occurrences in that second attribute of the table, and then it'll go down from there. Let's see. This will actually fetch the most common activities, but the front end will actually only display your most common activity, so it'll only show you one, what your most common is. I suppose I could show top 5 or something like that, like the top 5 locations in the future, but I didn't go that route. And then fetch the total activity time. This one just shows the amount of time that you have recorded doing any sort of activity in this location JSON. So this one uses the sum feature like I was talking about earlier. We're going to select the sum, the end time minus the start time as the total from raw activity segments. So this takes those two columns and it takes the value that is the difference of those two and sums all of those columns up. Referred to it as the total from raw activity segments, and then again the user ID, start and end time parameters that you can filter on, and you'll see that in the UI as well. And then we'll move on to the place visit data access object. These ones are a bit more interesting. So these queries utilize that join table, which makes them a bit more complicated using left joins, or that link table rather. So the idea here is that we want to see the most visited locations. The UI only displays 5, but this query returns all of them, and we flesh that out later. So we want to select the place name, address, and then the count of the raw place visit ID. So we really just care about the name and the address. You want to know the place that you visited most, and then of course we want to see occurrences, but occurrences are stored in the raw place visit, or at least the occurrences are stored in the link table technically, but you want to see how many times this place visit is linked to a raw place visit, and that's what this query does. We left join on that raw place visit, or this place to raw place visit table, and then our where clause shows again, where the user ID is equal to the user ID we have selected, and then the start time and end time is what we have set as well, and then we group by the place and name, and then we order by the count. So this one will show our most visited uh, locations for a specific user within a specific time frame. And then fetch the longest location visit. This one is very similar to that other one where we care about the name and the address. Instead of a count for that third attribute, we care about the end time minus the start time, and we select that as time. Um, and then again, we're going to do the left join using that link table to be able to grab the times stored in the raw place visit table because in this place table, there's only the name and the address stored. So we do that left join to link them up, and then the where clause again just shows or just lets you select or filter down to the user ID and then the start and end time windows that you want to show those in. We're going to order that by count descending to show the longest location visit first, and then from there on. And this proximity record query is probably the most complicated one. This one will allow us to show when two users have been within a certain distance, within a certain time of each other, and it returns all of the values associated with that. It doesn't limit it in the front end, so it'll return a list. Um, but since there's a start time and end time for each place record, there's 4 different time values that I could use to refer to as a timestamp in the front end. So I just decided to add all 4 of those up. Since your time window can be like 30 minutes, it might not be accurate to use uh, one or the other. So I just add all 4 of them up and divide it by 4 and call it the average timestamp. And then we want to grab the place 1 attribute, or sorry, the place 1 latitude and place 1 longitude, and then the place 2 latitude and longitude, and we use that to calculate the distance between the 2 records, um, the physical distance, and then also we generate an average latitude and longitude using those values as well. And then from the from clause uses the raw place visit and the raw place visit table a second time. So we're self joining here on uh, the place one's user ID equal to user one, and then place two's user ID is equal to user two because we want to select from the same table but for 2 different users. And then this where clause here gets pretty complicated where we um, want to ensure that the distance is within a specified parameter that we have supplied. So we take the difference between the um, latitude and longitude. We want to make sure that that is less than a specified distance, and then the same with the place 1 and place 2 longitude values. We want to make sure that's within a specified distance. And then here we have the absolute value for the start time for place 1 and place 2. We want to make sure that's within a certain time window. That can be set through the front end as well. We want to be able to make sure that we can specify the grace period for when these records are within a certain distance of each other, and then we do the same thing for the or sorry, not the same thing, but we can also specify here the start time and the end time of all of these records, so we can make sure that we only grab records within a certain time frame. Like say we want to grab stuff from, I don't know, 2015 and then run this on 2 users. Say there's a vacation or something and you want to see if Google has you recorded within a certain distance of each other. And that pretty much sums up the back end. This one was pretty long, but we'll move on to the front end now. Here I have the application up and running, and in another tab here I have the database up. Here we can see that it's empty because I haven't inputted any information yet. If I select multi-user statistics here, I'm able to use that proximity query that I demonstrated earlier if I don't select multi-user statistics and I just enter one person, that option will be grayed out. So we'll select one person here. And depending on the size of these JSON files, sometimes that parser can take a while to import it. The logic does work, but it's slow. It's not optimized. So we'll see how long this takes. And now that the information should be in, we can go back to our database here, and here we see that the information is populated. The user 1 is me, and the user 2 is Jason. Here, or user 1, raw location, or raw place visits. And here the activity segments are. See, in passenger vehicle is seems to be the most common activity type, but we'll see. And then what else is here? Oh, this is just that link table. And then the places being stored and linked to the raw place visits. All right, so if we select the top 5 visited locations query here, we can use this date picker, and I'll go back to, say, 2016, and you can pick whatever time you want for these date pickers. If you just leave, um, like if you just leave this some of these values blank, it has a default that is set for it. Um, I think this defaults to AM if I just leave it unset. And then we'll just do today for simplicity's sake. And then here we have the result is between between this date and that date. At these specific times, Caleb's top 5 visited locations are home, which is not surprising with 457 visits. I was expecting more, but Google actually condenses your raw location visits to optimize storage. So they just decide to store a single place visit and then just have a start time and an end time. So if it's recording multiple place visits and you haven't really moved, they're just going to extend the end time on that particular location. So then Central High School, Best Buy, YMCA, I used to work at these two places, and then friend's house. And we'll go ahead and clear that data, and we'll move on to close proximity. So for this one, it's going to compare Jason's data and my data, and it's going to give me how many times we're within a close proximity on a certain day, so or on a certain time frame. So we'll say 6 miles apart with a grace period of 30 minutes. Yeah, 30 minutes. And then I was in Sioux Falls with him around this time. So if I filter it down to that date, it should give us there we go. So between these 2 days, within 6 miles of each other and 30 minutes at most between records, Caleb and Jason have the following close proximity records. So here's our average latitude and longitude values, distance apart. So this query will, or not this query, but I think I have this implemented in the front end for it to sort with the shortest distance first, and then these are the dates that fall between these time frames that show we were about, this far apart, and this is our average location. So this should be somewhere in, if I punch this into Google Maps, this should be somewhere in Sioux Falls. Uh, yeah, Sioux Falls in South Dakota. So we'll go ahead and clear that out. Go to the next statistic, the longest location visit. Um, this one's pretty simple. So we'll do, I don't know, July 1st of 2015, and then we'll do today's date again. And then we'll do me. Here you can select between the two whose statistic you want to calculate. So between these dates, at that specific time, Caleb's longest location visit was at, and this isn't surprising, home, located at 2338 Point Place on this particular day, lasting 207 hours. Holy crap. I must have been sick on that day or something. Um, but yeah, that so that does that. And then the most common activity, again, pretty simple. So we'll do between, again, between these dates, and we'll do Jason this time. So between these dates, um, and that time, Jason's most common activity is in passenger vehicle, which isn't surprising because for some reason you would think it would be walking or sitting or something, but Google seems to only record location activity when you're moving. Or that's not necessarily true. That's just when they seem to record activity segments. I haven't seen too many activity segments outside of in passenger vehicles, so I don't know if that's a bug on their end. I doubt it, but uh, so that's the case there. And then with the last one, activity distance, here we'll do uh, we'll pick a time frame here again, just today, and then we'll use me. So between these dates, uh, I have 957 miles of activity distance recorded for myself. So yeah, that's the statistics engine, and then as soon as I don't have too many fail safes built into this application, so if I go back to the front here, I can enter more user data. It won't clear out the database until I go in there and clear it out manually, but it functions as intended for the most part. So that is my application.